I'm excited to be joined by Marni Ines, product development for Titleist irons, and we're here to talk about the all-new T-Series, as well as a lot of other cool stuff when it comes to design, engineering, materials, all of those things that I like to nerd out on. But let's start with the T-Series, and let's start with, for you, as someone who brings these things to life, of all the products that are new, what is the one that stands out as like, I can't believe we were able to do this?
Yeah, I mean, between the new T250 and T350, those are the ones that I would say are the most interesting in that if you remember the previous generation, right? Both of them had this polymer muscle on the back. So essentially there was a section that was a separate component that allowed us to put the max impact technology into the head, right? And then cover it up. Now, can't take credit for all of this, of course. Our innovation team came up with a construction where they came to us and said, hey, you know what? We're able to get that max impact core into the head and seal it up with all steel, and like you never even knew it was in there. And like, we looked at that and go, wow, that's pretty cool. I think, and with the look that we knew we could get with that construction, and feel as well, being a priority, that was something that we said, like, yeah, we need to go for that, for sure. And to be able to put all that business in the head, right, then seal it back up, there's some complex welding that has to happen and finishing to make it look the way it does. But, you know, to have all that in there and have it look the way it looks at the end of the day, I think was a pretty cool challenge and ended up great.
When it comes to like creating product and like ideating things like that, is that pushed by engineering, or is it something where it's presented from a manufacturing side of things with your partners where they can say, we can do this? Or are you taking an idea to them and saying, how can we make this become a product?
Well, it's actually maybe coming from a slightly different angle where you're asking yourselves, well, can we do this? So yes, from R&D, right? Can we make something that has this technology inside the head, but be able to finish it as if it was just completely solid or looks completely solid, right? Gives you that muscle look. And so, you know, it definitely comes from R&D where you want to, how do I want to say this? You want to keep all your technologies, right? But put them in a package and a look and give yourself material advantages that allow you to have the best of all worlds, right?
Yeah.
Because there were some things with the polymer muscle where there was some like kind of sound feel, deficiencies from that type of construction that now an all metal back affords us. But by going to this all metal construction, you're also creating other complications in manufacturing to be able to have it all, right? But we like to push through those challenges, and you see what we got here.
It's kind of like it's pulling levers, right? Like it's utilizing materials, utilizing manufacturing techniques, and putting them into something where, the way the irons are designed is like from my understanding, is like it fits into that segment of the fitting market. So how does it fit the player? And each one has those unique challenges to bring it together, right?
Right, absolutely.
How, speaking of materials, something that I know you guys use a lot of, tungsten.
Yes.
How important is tungsten in designing products like this, where if we think of an iron, and I think from like the club building brain side of my head, is like, if a 7 iron weighs 270 grams or 268 grams, you can only have, from an engineering perspective, 268 grams to work with.
That's right.
So how do you pull those levers and use those different materials to say, we're gonna use as much of X material, and this, for you guys, it's a lot of tungsten, to make it perform a certain way,
sure,
feel a certain way? Is that what that material really is utilized in because it is so beneficial?
Yeah, the two biggest things I think that tungsten affords us, right? It allows us to place the center of gravity very precisely, right? But do it in combination with giving the club head great stability, right, through high MOI, right? Because we have intellectual property around using really large amounts of tungsten in the heel and toe, right? So that gives us an advantage in being able to have that combination of CG placement and MOI within our given products, right? And tungsten is very efficient, right? It's very dense, so it allows you to place a lot of weight into a very small volume, because these aren't very large.
Yeah.
These aren't very large volumes to work with, right? So you're wanting to be able to take that weight, push it as far out and as low as you can in a long iron to help you get that club head stability and that launch from a lower CG.
Yeah.
And then as you're working your way through the lofts up through the 7 iron, you're also trying to maintain that same combination of having high MOI, because you want all your clubs to be as stable as possible, and also manage the CG, which actually we want to progress. So our CG progression is from lower to higher in the shorter irons, where that tungsten is also helping you do that very efficiently.
So if we go through, we started, let's say we start at the 100, and we talk through the design changes that are outlaid in specifically that product, but as well as the rest of the line. From the 100's perspective, from, again, listening to the presentation earlier, one of the biggest things is technology from the T150 has moved into that club to help with, you say, compliance on the face of the longer irons, right? So it helps with ball speed.
Right, helps with ball speed and launch, right? So, and both of those equal height, right? Which was really the goal, right? So we wanted to get more height out of the 3 and 4 iron, which we'd seen drop off in use, probably because we had a 150, probably because we also had a 200 that you could just put in the bag and they could see, you know, added launch and better gapping, right?
Yeah.
And with better descent angles. So, you know, by taking that technology from 150 and moving it into the 100, we're now just giving our players another option in that part of their bag, where instead of maybe a 150, maybe the 100 works for them, and it's in a size, offset, and shape that maybe they prefer, right?
Yeah, and then for the 150, a lot of the change isn't so much around the technology that's built into it, but the geometry around the head to help with MOI, as well as just getting more stable MOI, and then also balance out the looks.
Yeah, balance of the looks for that category as well, right? So we felt like this was a product that could get slightly larger for that category, and that player would appreciate that larger size. So we increased the blade length by 1 millimeter, and I like to say that, you know, the shape, because it's coming from the previous 150 where we just widened the top line and the sole, it's a better proportioned shape now, because with that extended blade length, it fits the top line thickness that we had in the previous generation better.
Yeah. Now, where does that feedback come from? I mean, obviously, I'm sure everyone on your team is a golfer, but you also work with the best players in the world. And not only that, but between the T100 and 150, you have basically the most used irons on the PGA Tour. So is that feedback coming from them and the tour of those who use them who are looking for something else, or does it come from the engineering team saying, like, I think we can do a better job of creating better proportions, and then taking that idea to the tour players?
This one actually came from, we actually had a meeting of our board of directors, and one of them had mentioned, like, hey, what do you guys think about making the 150 a little bit larger? And with the changes that we knew we were going to make in terms of the all metal back construction, and with the other differences that we're putting into the 250 especially, or sorry, the 150 and the 250,
yeah,
we knew that would be a good move, right? Because that's only going to help us with moment of inertia. And from my standpoint also, I thought about it and said, like, yeah, the shape would be more proportional to me with that added blade length. So it's kind of a win-win.
Okay. And then from there, like, the 250 looks smaller than the previous 200.
I think that's more finish, right?
Yeah.
Because it's actually larger, right? It's actually larger.
Yeah. It's like a little trick, right?
Yeah, so that product is actually 1.5 millimeters longer in blade length than the previous T200. But again, if you saw, or if you look at what we've done with 150, because all of these were very similar in blade length in the longest irons, you couldn't increase the blade length of 150 and still keep your progression, right?
Yeah.
We had to go larger in the 250 as well. But again, we felt like we could do that with the changes to the construction. It's going to help us maintain some high MOI in that product. And again, I think most people would look at that shape and go like, yeah, it looks great. It's not like it looks like it's elongated or too long heel to toe, right? We do a good job, I think, of shaping these products to keep them consistent, which is part of the blended set strategy that we have, to have them look from a dress like there's not really a huge jump from one to the next, right?
Yeah, and then you have the 350, which goes even longer.
Correct.
And so every time you change that blade length, you're increasing MOI.
Correct.
Right?
Correct.
Just because, again, you're moving mass away from the center of gravity.
Right. It's easier to place it farther away from
Yeah.
center face.
And a big thing with the 350 is the way that it basically progressively moves throughout the set. Just like, again, because the short irons are not as big as the long irons in the 350.
Right.
So you have this set for golfers who are looking for a lot of forgiveness. But when it sits in the bag, I mean, it doesn't really look that much different than a 250.
Right, and I think that's part of the reason why most of our iron sets are progressive blade length, right? So it's shortest blade length in the short iron, longest blade length in the long iron, helps where it helps you get MOI, club head stability, where it allows you to get wider soles up there, allows you to help get those performance properties to help the golfer hit a 3-iron well. Yeah. Right? Versus hitting a pitching wedge, where most people can hit a pitching wedge, club length is shorter, it's an easier club to hit, and most people aren't asking for, at least in my experience thus far, a large short iron, right? So, so our set, especially in 350, you'll see that the short irons are quite compact. They're still bigger than the other short irons, right? But you can put that club down and it doesn't look chunky. Right? It still has a nice compact look to it, but it's got all the forgiveness in it that we can pack into a model.
Now, before we get into the utilities, there's one more club that's part of the set that I think is very cool. I know I got a chance to test it today, and the first shot I hit with it, I kind of like looked at my normal window, then I had to look up really high, and I just started laughing. Because it almost, for me, it was like, wow, I cannot believe that I actually did that with the golf club I was hitting. And that is the 250 launch spec. Or as it might look when someone looks at the back of it from an aesthetics perspective, there's the star on it. And this is something brand new that you guys have done. And can you tell me about why that product is so important in the marketplace for the golfer that it's designed for? And it is a wide swath of players. This isn't just designed for what you would say the lower swing speed or the junior player. Like there's this huge group of golfers there that need something like this from a performance perspective to help them play better golf.
Right. I mean, the simplest way I would put it is that it's for players who need launch, right? So people who are struggling to get height out of their current set. Secondarily, it started off talking about juniors, right? So juniors and especially emerging juniors, their lower swing speeds don't allow them to generate as much launch through speed. And so how could we help them? But then you look further at who else has similar speeds there. You could have aging golfers. You could have some women in this category as well that all can use added loft to help launch the ball in the air. And it's a really exciting product for me because it's the first time that we've gotten to marry all this technology that we put in these irons, especially irons like 250 and 350, with more loft, not stronger loft, right? So being able to have golfers really focus on getting proper trajectory into the green, land angle, and stopping power to be able to hit it closer to the hole. as an iron designer, that's excites me, right? Because it's been more challenging to go through everyone wanting distance, right? It's like everybody chasing like the driver craze of like, I want to hit it farther, than having to manage trying to get acceptable trajectory with stronger lofts, right?
Yeah.
So
I would say you were not responsible for this, but I can remember about a decade ago working in a fitting studio, and as someone who built golf clubs, there was a period of time where it felt like irons became very strong and very low spin to the point where there were certain sets that would come through all the time, and it wasn't just one company, you'd get them from all different companies, and the first thing on the build sheet would be bend 2 degrees weak. So you'd get every set, you'd bend them all weak, then you build them, then you check them, then you make sure, because loft, or I should say lower center of gravity and lower spin is only helpful if you can continue to manage trajectory.
correct.
And for golf, like I saw it where like I have no problem with height. That's a swing thing. It's not an equipment thing. It's just my golf swing tends to create height. So to see that, I was like, holy smokes, like that's insane.
Yeah.
Like I could, like, what's the lowest iron this thing goes to? Because I'll hit this thing in the air, right? Because I do think having fit golfers, people think, or I get to go see, I always joke like this way. I put it this way. When I go to a tour event, I'm lucky to go to a lot of PGA Tour events and just observe.
Right.
It's great to be a fly on the wall and watch some of the best players in the world hit golf balls on the range. And you see everyone from moms and dads to grandmas and little kids along that back gate. And the first thing they always say is, oh, they hit it so high. It's like, that's where you're supposed to hit it, rather than trying to like launch these little bullets that don't hold greens.
Right.
And to be able to empower that to players, to have them hit more greens is like a big deal when it comes to, from the engineering side, that actually goes out to fitters and says, look, we're gonna help you stop the golf ball close to the hole.
Right.
Than having it just roll through the back all the time.
Yeah, and I think from the interesting thing that we'll see hopefully going forward is that most players who are launch challenged, right, who need this product, should be able to go from their current set and be able to have a similar range of distances in their bag to what they had, but have the scent angle. They may have to add another long iron into their bag to get the same range of distance, but they should still be able to get there, and with everything in their bag, they should have better descent angle into the green. So that's the hope anyway.
It makes you think of the, like the garden hose analogy I always hear is like, if you want to spray water further, you don't point it down, you point it up.
Right.
And just to get golfers to hit that, like that window that everyone talks about. And the window is really derivative of clubhead speed, but to be able to find the perfect window for that golfer is going to make a big, big difference. And you can, I think what's really cool about the T250, the launch spec model, is the fact that for golfers who need that, they're not looking into their bag and seeing a club that looks completely different.
Right.
It looks like the 250. There's just the only difference being there's this little star on it.
Right.
Which for me made me think of the Pro V1X, I think of like the left dash is like the high launch, low spin.
Sure.
It's like the star for this model is just like higher launch, stop faster.
Yeah, it's really a fitting option, right? And what we also found was that for a lot of this category, lighter weight is another thing that would fit well for this player. It's probably also going to couple nicely with our GT1 type product player as well, right? So. We'll see. Because being able to couple loft with technology now, I think it's a very unique product in the marketplace now, and we're excited to see what it does.
So let's move into the utilities, because it's something that I really enjoyed hitting, and there is the 250U, as well as the U505. Now these are very different models, just even from a looks perspective, but the T250U is a change because you now have a different hosel for accepting different shafts. But all of the technology that's in the iron is powering that utility, but it's just shaped just slightly different, correct?
Yeah, so it's slightly heavier to be able to build with hybrid shafts, right? So we also have a 370 bore in these products to use those shafts versus previously we had a taper tip bore, right? And
Yeah.
we were actually shaping hybrid shafts previously to fit in that bore. But we're like, well, if we're going to use hybrid shafts in these, well, let's just give the proper bore for those and leave it. Because we still have the 250 and taper tip, right? You can still build a 2, 3, 4 iron with taper tip, iron shaft if you want to, but it's the utility build, 370 tip, we just figured it makes sense. Let's just do it that way.
Yeah. And with the U505, we talked earlier about like the iron blade length. Like the blade length is pretty progressive in that model as well. So for golfers as they move into the lower lofts, they see that profile change slightly, right? Just for
it's actually similar blade length throughout the lofts. However, what you're noticing is the change in proportion, right? So this new progressive shape that we have in 505 came from the fact that we had a prototype 3-iron T350 on tour, and when we put that product out there, that really gave that shape some credibility as a potential utility iron. So what we decided to do was then, okay, let's use that in the higher lofts of the U505 and make this progressive shape from the current 1-iron shape to a T350 4-iron, right? So now the 3 and 4-iron are very much T350 shapes with the offset of the 100, 150, 250, right? So it's nicer to blend with those models in terms of offset. And now you've got a shape that we all believe is definitely more confidence inspiring than the previous one in those lofts. Has a slightly deeper face now, right, top to bottom. And you know, the response from the tour players has been great with that one as well.
Yeah. Now, again, I think the whole thing is really cool. But like one of the questions that I always have that drive me like kind of like really curious is, you already made great product. So what are the challenges that come with building something like a T100 and refining that product?
Yes.
When you've already got something that works so well? Because I think, which I was like, again, it's one of the reasons why I like F1 is like the engineering side of it, because the rules change every couple of years, so they have to make changes to like the cars. The rules of golf don't really change, but you have players who are looking for different needs. So what are the design challenges when it comes to saying like, okay, well, we're going to make something newer, we want to make it better. How are we going to do that?
Right. Well, in the case of this new T-Series line, there was really a couple of goals that came through clearly, right? There was increasing long iron launch and height, and then there was also improving spin from that first cut or slightly wet condition in our mid and short irons, right?
See, I was going to ask you about this.
Right? Yeah, because we could totally, we were doing some testing on tour, and we saw an opportunity there to improve in that area, because we had a couple of players who, their attack angles would cause, a slight jumper here or there, and like, okay, well, let's take a look at that and see what we can do. So now we have progressive grooves in our irons where between the mid and short irons, it's one groove, and then in the long irons, it's a different groove, right? And that allows us to have more consistent performance, especially from this first cut or slightly wet condition with these different parts of your bag, right? And so the challenge there was really just, okay, finding like where's the right place to make that break.
Yeah.
And then also like with long irons, it's always challenging without changing the geometry too much, right? Because it'd be real easy to make a really wide sole product and drop a bunch of weight in the bottom, right?
Yeah.
But we aren't affording ourselves that luxury, right? It's like, it's pretty much gonna hold the same shape, but how can you further improve height, right? So you can improve it through adding speed, through adding launch, right? And you can use center of gravity, and you can use COR.
Yeah.
And so in products like 250 and 350, we afford ourselves high COR in a 250's case. We afford ourselves maximum COR in a 350's case, because we believe that the 250 player because their priority is not maximum distance, we afford ourselves to not go as fast and be able to control the speeds across the face better, because it's harder to control speeds all the way across the face when you go to maximum COR.
Yeah.
Because you're going to have that spot on the face that's just really hot, and then you coming back to spots on the face that just aren't as hot, right?
It's like you have, I use car references all the time. It's like,
I like cars.
yeah. So like when it comes to like a T100 and T150, right? Like in many ways, it's like you've designed a Porsche 911, and people really like the Porsche 911. So we don't want to change it too much. But we want to tweak performance a little bit to find it. So when it comes to the grooves, for example, how many iterations does it take? Like, do you have things that you test in the past that you bring to it from, say, the wedge team, or is it something where like we've tried these different grooves before and we find that say we put this groove on a 5-iron, it actually spins too much, it doesn't do what it's supposed to do, but then we use another groove in the short iron and it does what it's supposed to do. Let's make it progressive. Like, how do you iterate to create that variation?
We certainly have tried. We've tried some spin milled grooves in some of our short irons, right? And what we found in some cases is that, well, you might get a player or two that spins it too much, right? So we really look to design a new groove, especially for 100, right, in that mid and short iron space, that provided similar spin from the fairway, but increased that spin from that first cut of rough, right? So that was a challenge in and of itself to do that. And so that's where we ended up with the groove that we did.
Now, is that through practical testing, or is that through simulated analysis that you have to do that?
It's through testing. You do a lot of robot testing, and you do some player testing, although it's really tough to do player testing in rough and get consistent, amount of grass behind the ball, all that. So we have a test that we do with our robot and some simulated rough material that we put on the golf ball, along with water, of course, to help us gauge that, right? And then when we take it out, so really to tour players, as long as we're seeing an increase from that condition, we feel like we did our job, right?
Yeah. Now, that's like, see, I like talking product, but now I got to ask the Marni questions.
Okay.
What, having been your background, I know we talked a little bit before, was mechanical engineering.
Yep.
Was it always golf clubs?
No.
What made you want to do? What made you say I can design golf clubs?
Yeah. Well, I started playing golf, right? So that was the thing. And it's funny because the first time I played golf was with a friend of mine in college, and he told me, he's like, "Hey, do you play golf?" I'm like, "No, my grandfather plays golf, but I don't really play golf." He's like, "You need to play golf," And so we were going. We were at UCSD, so not far from, Torrey Pines, but there's all these golf shops. Pro Golf Discount was a shop, and he says, "Get in the car, we're gonna go Pro Golf Discount and take a look at some stuff." And he points out to a set there, and he's like, "Here, buy that." It's like an $89 set. 14 clubs, bag, everything, right? And so within 2 to 3 hours of him saying, "You need to play golf," we're on the first tee at Mission Bay with my new set, right? And I'm just rolling it around, of course, right? It's the first time I've ever played. But it was like the 12th or 13th hole, tee up the 3-wood, and I just remember puring one down the middle of the fairway, right? And you just get that
the feeling.
Right, that feel, right? And like,
it's a drug you've been chasing ever since your friend took you.
I guess, right? And it was like ever since then, it's like, I want to do that again, right? So after that, I was looking at, instruction and all these different things to try and get more into the game. And then one of my jobs that I had early in my career, they had a golf league there. And so when I joined the golf league and got a little bit more competitive there, then I really got the bug to say, hey, it'd be really fun to design this equipment, right? Because I was probably about 5 years into my engineering career at that point.
Yeah.
And like, it'd be fun to design this equipment, come to find out they're all half an hour up the freeway from where I was. So that was it. Started throwing my resume out there, and then finally got into the golf industry.
What was your first Titleist iron that you designed? Or you were part of the team that designed it?
Sure. That was the 712 series. So there was an AP1, an AP2, and there was also a CB and an MB product in that line. Just four products.
Those, I can remember being a junior golfer, and like the first AP2s came out, and I felt like they were everywhere. I felt like it was a club where it was one of the first clubs that ever melded technology with a player's golf club. Just like player's distance when I was growing up was not a golf club category. That was not even like a thing.
Right.
And it was either you played like a big cavity back or like a mid-sized cavity back, or you played a really small forged cavity back, and then you played a tech iron.
Yep.
There was no melding of the two really.
Right.
And from a junior golfer who, when those came out, it felt like that was a big thing that really changed the way iron design kind of pushed forward as far as providing ball speed retention and like utilizing different materials. Because that one had, rather than pushing the tungsten on the heel and toe, that was the box on the back was nickel
Cradle,
tungsten, right?
Yep, that's right. That's right. So that was, again, it was tungsten, but it wasn't as dense as what we're using now, right? So that was probably more in the order of like 10 grams per cc versus now we're using like 18, 80% more material in the same volume, right? So it's pretty cool to have access to that material. But I also remember about 712 though, is like seeing guys like Ben Curtis and Zach Johnson having, like Ben Curtis had a set, but like Zach Johnson had a couple long irons in his bag, you know, and it's like, wow. So even in this category, these players are realizing that there's something to the performance of these products. And in Zach Johnson's case, the long irons, where it's like, wow, you know, I'll play it. I don't care how big it is. It just what matters to them is that it's performing.
Yeah, I remember being again, my club building brain was going nuts one time, and I knew tungsten was really heavy. So being the kind of person that I am, I went to the periodic table. And I was, okay, well, what's heavy?
Yeah.
It's like platinum. Okay, well, I'm not putting platinum into a tip weight. Gold, okay, I'm not putting gold into a tip weight. Tungsten, okay, this makes sense now.
There you go.
Right? And
as heavy as we could find.
Yeah, and it's so interesting how that, like a material that is like a pure element basically is something that is so useful when it comes to club design because of its mass properties. It's almost twice as dense as steel, is it? Am I trying to?
Yeah, it's more than twice as dense. Like the steels we use are like 7.7, 7.8, and we're using 18 grams per cc tungsten, right? So
titanium is like 2 point something, or?
I think it's like 4.7, 4.8.
Okay.
And then aluminum's like 2.7.
Oh, okay, okay.
Yeah,
it's like, and like knowing that like, unless you're gonna start putting gold and platinum into golf club heads, which I mean.
Or depleted uranium is another one, you know? It's another one.
Might be a little cost ineffective. How is it when you are searching and looking for materials in golf clubs? Is it because I think of like the Metalwoods team in 425 ATI.
Yep.
Like that is something that allowed them to push the envelope.
Yes.
For you, is tungsten that metal, or is there something else as far as, say, steels on the face that can be thinner and stronger?
Yes, I don't know if you remember a product line called CNCPT.
Yeah.
Right, so there is a face material in those products. It's quite expensive, has a long lead time for, and a minimum order quantity. So you have to order so much of it.
Yeah.
And you have to order it at least 6 months in advance if you want it, right? But we felt it was worthwhile to try it out, you know, in those products. And in those products, that material made it very easy to get high COR because it was very strong. It's a very strong and ductile material. It's a great combination. But it's very expensive, of course. And then the other reasons I just said, long lead time, and you have to order so much of it. So there are materials out there. What I would say is that, one, we have a material scientist who's always looking for us. He's always searching journals and things like that. But two, really anything that gets used in automotive or aerospace, if there's some material advancement there, we are likely going to be interested in it. So we're always looking at those industries to see what's next.
I remember someone saying from a shaft company, a lot of shaft companies are driven by aviation because they try and make these planes more fuel efficient and lighter and obviously strong and durable and malleable, right? Like you see planes and their wings, they flex, like flexing, they have to flex. They need that ability to rebound and have that strength. And I remember someone explained to me, like, we use those types of carbon fibers and resin and all those things. We engineer that. We take those and we thank those really, really huge aviation companies that do all the research and development. And then we say, hey, maybe we can use this in a golf shaft.
Right.
Because I think of like landing, like carpenter steel and those really hard steels are used in like airplane landing gear. And that basically becomes an iron base.
Right. Yeah, it's true. It's true. And they're really strong. They have a level of ductility that allows them to flex and not be too hard and too brittle, right? Because that's the other thing that you're fighting with using high strength materials in faces, especially. Like, you can get something that might be really strong, but it might also be really brittle, in which case, in our types of impacts, you're going to get cracks, and it's not going to be a durable product, right?
What is the most fun part of your job? Is it designing something and, like, say, seeing it in 3D space for the first time, whether it be through, like, if you utilize 3D printing just to, like, get shapes of things? Or is it when that first head comes in from, like, a production facility and it's got a shaft on it and you're like, I really want to go and hit this thing?
There's different levels of it, right? Or different moments. Like what you just said, when the first parts come off the tool and you see the design, and you're holding it for the first time and going like, okay, here it is, it's pretty cool. But then it's also another level to put it on your robot, test it, and see that, okay, now you're seeing the trends and the performance that you wanted. And then you go out, like I did last week for the tour launch, you're bringing all this product out there, you're putting it in the hands of the best players in the world, and now you're seeing the performance realized through their swings. That's pretty fun, right? I mean, it's like watching your babies go out into the world, and do their thing, right? So
that's cool. I can imagine it too, because there's so much time that goes into it. Like, when you, from a general perspective, how far ahead or what is actually, no, let me phrase it this way. Do you find that it's a huge benefit to offer a 2-year cycle versus a single cycle because of the time commitment and investment that goes into making sure that your products are engineered so when it goes into players' hands, they are ready to go?
I definitely believe so. And it's because, to make advancements in these products is hard enough without giving yourself more time, right? I'd take more time if I could, but we know that right now with our current product life cycles, we seem to have a good rhythm going on right now. But 2 years, even 2 years in and of itself is challenging to do what we do, especially because we like to push ourselves, right? So we're pushing ourselves and challenging ourselves to take these designs further, push our materials further, push our suppliers harder to get the processes developed that we need to improve performance. So that in and of itself is a challenge, right? Even within a 2-year period. So I can imagine trying to do that in 1 year. That's,
a lot harder, right?
Yeah, be absolutely a lot harder. To get some meaningful performance difference there, for sure.
What I know I asked about your first club. Are these your favorite now? Are these your new favorite?
They're pretty fun. I still say, like, the designing concept product, the CNCPT line, was pretty fun, right? Because you're afforded, like, just do what you need to do to try and make this product outperform, right? And so we're still even looking at, like, oh, well, what would be the next concept product, right, that we could do that would you know, put something out there that's different and new and pushing the limits of performance. But as far as mainline stuff goes, yeah, definitely this is our best work for sure.
Because in reality, kind of like I know we've used the car analogy a couple times here, but the goal is just like a tour player. The goal is to get up and be better. The goal is to have that desire to say, look, we've achieved this level of performance. What are we going to do every single day to try and find that next level of performance? Now, tour players might do it in the gym or on the range or with their coach. You're out there doing all kinds of stuff. Like, you know, I remember the video where you're hitting the irons and you're doing that, like the anechoic chamber, which is like a cool video.
Yep.
And you're hitting marshmallows.
Yeah.
I think you might have eaten a couple of those while filming.
They caught me, yeah.
Yeah. Because that's got to be pretty fun to be able to say, like, look, we're gonna try and make better, but we have to like find these avenues, right? Like, you got to go down these little like rabbit holes to come back up and say we're good to go.
Right. Sure. Yeah. I mean, it's always a challenge to try and outdo ourselves, right, with these products, especially a product like T100 where it gets a lot of play. It's got great feedback from the players, and you don't want to take it into a space where now all of a sudden you've made a mistake and now all those players that loved it no longer love it, right?
Yeah.
So it's a balance of evolving these constructions enough to get a meaningful performance difference, but not changing it so drastically that now you've kind of scared a player away from it being too different from what's in their bag.
I'll end on this because I always think this is an interesting one, because you know you're out at a place like Colonial when you launch the irons. What's the best piece of feedback you've ever heard from a tour player about something where you've given it to them and they just go, I can't believe you did this?
The best piece of feedback? I don't know. It's more of like seeing them be as joyful and happy at what they're seeing as I am, right? And seeing them have fun with the product. Like, we spent a little bit of time with Cam Davis, who, upon getting his 3-iron 505, hits one 142 some odd feet in the air. And I'm like, man, you know, that's high. And he was going back to his bag to throw it back in his bag. And I said, man, that's high. And he's like, oh, you wanted me to hit one high? So then he goes back and then he hits another one. And it's like 172 feet in the air. I'm like, I think that's the record I've seen, you know, for peak height of any iron being hit anywhere.
And like you said, that was in a high lofted golf club.
Yeah, it was a 3-iron. Yeah, 3-iron 505, 172 feet. I mean, that's unbelievable to see.
That's cool.
But yeah, so that's fun. Yeah.
Thanks, Marni. Thanks for your time.
You're welcome.
Appreciate it.
Yeah, it's fun being here.